You're welcome to Basic Organic Chemistry class. In today's class, we're going to look at the fundamentals of organic chemistry. At the end of this class, you're going to understand some basic things that will help you understand organic chemistry efficiently. So, ride with me. First is understanding what this organic chemistry is. This is simply the chemistry of carbon and hydrogen. That's why we simply have hydrocarbon, that is hydrogen and carbons. Besides this hydrogen and carbon, organic compounds or organic chemistry is also chemistry of other elements which are oxygen, nitrogen, sulfur and halogens in these hydrocarbons. And this carbon exhibits a unique capacity or ability of bonding with itself in covalent form to form a longer chain called catenation. So catenation is a process by which carbon bonds with itself to form a long carbon chain. Atomic orbitals. From the electronic configuration of carbon, we already know that carbon, the atomic number of carbon is 6. And these 6 electrons are divided into atomic orbitals. Now, for carbon, we have only s and p orbital. An s orbital has maximum of 2 electrons, exhibiting only 1 orbital, while p orbital has 6 electrons, meaning it's going to have 3 orbitals. D has 10 electrons, meaning 5 orbitals, while F has 14 electrons, meaning 7 orbitals. But in organic chemistry, only s and p orbitals are always being used in hybridization. Looking at the atomic number of carbon, in electronic configuration we have 1s2, 2s2 and 2p2. 1 is being highlighted red because in hybridization, the first energy level can never be part of hybridization because it is not on the same energy level of 2. So we are going to combine orbitals that are on the same energy level, meaning 2s and 2p are going to combine in hybridization. Shape of s orbital is spherical, and at the center of the sphere we are going to have nucleus. This s orbital is going to have 2 electrons that are being arranged in opposite spin as proposed by Pauli. Then p orbital is going to have 3 degenerate orbitals, which are px, py and pz. These 3 degenerate orbitals have equal energy, shape and distance, and the shape is dumbbell. We need to understand what valencies are. Valency means the number of unpaired electrons an atom will have. It can also be referred as combining power or combining capacity of an atom of a given element. Example is looking at carbon. In ground state, carbon is going to have 1s2, 2s2. Remember, p has 3 degenerate orbitals, so p is going to be 2px. The first electron will enter, the second one will enter into y. Because there are only 2 electrons on p, is going to end in y. This happens in ground state. Why in z there is no electron? But for a reaction to occur, this carbon is going to be in a excited state for it to bond, for it to hybridize. So in excitation state, S will say I have 2 electrons and P does not have 1, and we're in the same class. Since I'm happy, I can let go of my 1. So S is going to share the 2, taking 1 and releasing 1 to Z. So both S and P are all having 1 electron each. No one is empty. This is the state at which carbon form bonding. That is why we have 4 unpaired electrons in saturated alkane, making the valency of 4, which is tetravalent. So whenever carbon want to combine, want to bond, the valency of 4 must be maintained. Whenever you're talking about the structure of carbon, Drawing the structural formula of carbon, valency of 4 must be maintained. Carbon is tetravalent. What is actually hybridization? Simply means mixing of two or more atomic orbitals of the same energy level to form a new hybrid orbitals. Now, the key word there is that there must be a mixing, and that mixing must involve two or more atomic orbitals. And these atomic orbitals, they must be on the same energy level, and they must form a new hybrid orbitals. They are not just forming hybrid orbitals, but it's going to be a new hybrid orbitals. Example is what we talk about in saturated system of alkane. Alkane is going to have sp3, alkene sp2, alkyne is going to be sp. We are going to understand how this is formed in the next slide. Now, this is carbon in ground state, where the Pz does not have any electron, and the 2s is going to have 2 electrons, because remember, for electron to move the next energy level, the lower energy level must be filled. So that is why 2s is filled before going to 2p, and unfortunately 2p has just 2, so it cannot fill all the orbital. But when they are excited, everybody is happy, so they realize that Pz does not have anything and is hungry, needed something, and 2s has ss. 2s said, okay, I can share. So 2s let its own one and gave to 2z. So everybody has something. That is what happened in excited state. Remember, because 1s is not on the same energy level, it is not taking part in hybridization. So that is what happened in saturated system, where the 2s and the 3p are involved in hybridization, forming sp3. In sp2, the 2pz will not be available for bonding, so it is going to be used to form a double bond. That is a weak bond. So that is why we are going to have s and 2p, making it sp2. So that's why whenever you're talking about unsaturated of alkene, you're going to talk about sp2, because pz was not available for bonding. So when we talk about triple bond, we're going to have sp. How sp? Because the electron in y and z are not available for bonding. So they are there to form a weak bond, which is pi bond. So that is why we are going to have only one s and one p in hybridization. So the only atom that will mix for triple bond is only s and p, making us have sp hybridized for our kind of triple bond. So that is how hybridization occurs. I hope this is clear. Now, looking at this slide, you understand something. The first column, we are talking about tetrahedra of sp3. In this sp3, if you look at the valency, the bonding is 3. There is no double bond. Everything is saturated. So that's what happened in alkane, and the shape is tetrahedra, and number of sigma bond is 4, because all the bonds here are sigma bond. But when you come to alkene, where we have double bond, the number of sigma bond is 3, because we are going to have one pi bond. Remember, the pi bond is the Pz that never participated in bonding. Y are Px and Py plus X are all single bond, meaning we have 3 single bond and 1 double bond, making the shape to be trigonal planar and the hybridization sp2. But when we come to triple bond, we are going to have 2 pi bond and 2 sigma bond, because Py and Pz was not participating in bonding. So that is why we are having 2 pi bond and 2 sigma bond. So, and the Hybridization here is sp and is linear. In linear, we are having angle of 180. In trigonal, we are having angle of 120. In tetrahedral, we are having angle of 109.5 degrees. So let's go to a typical example of hybridization. How do we apply this hybridization in compounds? If you look at this compound, we are talking about the hybridization of carbon. You can also have hybridization of bond. Now, this one we have hybridization of carbon. Looking at these two carbons, because these carbons are connected to double bond. Carbon 1 is sp2, carbon 2 is sp2, carbon 3 is sp2, carbon 4 is sp2. All the carbons are sp2 because if you look at carbon 1 is connected to double bond. The carbon 2 is also connected to double bond behind. Carbon 3 is connected to double bond in front, while carbon 4 is connected to double bond behind. So all of them are sp2 hybridized carbons. Looking at this example, when you're given a question on hybridization and you're given a compound like this, the first thing you need to do is look at each of the carbon or any atom like nitrogen, oxygen, or whatever that is there and indicate their individual hybridization. The carbon of saturated system having 3 hydrogen is sp3 because the other bond is being used in catenation. So remember, in tetrahedral we have 4 bonding. This 4 bonding can only occur in methane, but in other alkane we are going to have terminal carbon to be 3, while internal carbon to be 2. So because of that, the first carbon is sp3. Then the second one, looking at the double bond, both the terminal carbon and the connecting carbon are all sp2 because they are connected with double bond. Looking at where we have oxygen, because of that double bond is sp2. And look at this ring where we have oxygen, but because this oxygen is connected to saturated, not unsaturated, it becomes sp3. So it's not compulsory that wherever I see oxygen it must be sp2. No, depending on the bonding connecting oxygen. Oxygen in alcohol is sp3, while oxygen is carboxylic acid can have sp3 and sp2. So carboxylic acid is made up of carbonyl and hydroxy. So the one of carbonyl is sp2, the one of hydroxy is sp3. Now, if you look at this carbon, the carbon that is connected with triple bond, both carbon are sp. And another one is nitrogen. Nitrogen is sp3 because if you look at it, it's connected to saturated system. So wherever I see saturated system, it is sp3. When you see unsaturated system, it is sp2. And super unsaturated, when you talk about triple bond, is sp. I hope that's clear enough. This is another example again. Whenever I see saturated system, like I said, you're dealing with sp3. A typical example, we can see our nitrogen here is saturated system. Then the first oxygen of hydroxyl is sp3, while the one of carbonyl is sp2. Now, when you have hydrogen, assuming the arrow is on hydrogen, hydrogen is s. Remember, hydrogen has 1 atomic number, so it's going to be 1s1. So it means that the only electron there is on carbon on first s orbital. So the hybridization of hydrogen wherever is s. So we're going to look at revision question. The first revision question is, who introduced the concept of hybridization? Like I said, it is Pauling. The phenomenon of forming completely new atomic orbitals by intermixing them is known as hybridization. Remember, hybridization is a process or concept of combining 2 or more atomic orbitals that are of the same energy level to form new hybrid orbitals. The next question, the orbital that are resulted from sp3 hybridization have that percentage S character and that percentage P character. Remember, sp3, if you divide 100 into 2, you realize that S in the ratio of 1:3, S will have 25, while P will have 75 because P is more. So it's 25/75. What is the valency of carbon? Carbon is tetravalent because because from the lecture we had, you realize that in excited state, all the S and P, all of them will have one electron in their orbital, making carbon tetravalent. How many sigma and pi bonds are present in the following molecule? If you see a compound like this, assuming you're in the exam, you don't have idea of this, you employ elimination method. In the elimination method, you can start from the known. The known, I know that I have pi bond is 4 pi bond. So that alone is enough clue for me to choose A as an answer. Assuming that is not enough, remember you're going to arrange all the atoms in structural form, meaning that the carbon that bears CH is going to have extra sigma bond. One bond is carbon connecting to carbon that bears nitrogen. Another bond is carbon connecting to hydrogen. So the first carbon nitrogen is going to have one sigma bond. Second carbon to carbon is going to have second sigma bond. Third carbon to carbon is going to have third sigma bond. Carbon to hydrogen is going to have another sigma bond, making it 4. Then carbon to last nitrogen is going to have another sigma bond, making it 5 sigma bond and 4 pi bonds. The next question, the orbital that are resulted from sp hybridization have dash percentage S character and dash percentage P character. Remember, S and P, they are equal, so they have 50-50, 50 S and 50 P. If you go back to the lecture, you realize that what gave us SP is 1 S and 1 P. So they are contributing equally, making it 50-50 S and P character. Now, what is the hybridization of each carbon atom? I want to make this clear. There is two different. Now, the question can be hybridization of atom or hybridization of bond. Whenever you're talking about bond, you're talking about two atoms that are connected with the bond. But in this question now, we are dealing with hybridization of carbon atom. So let's look at it. The first one, carbon 1, if you look at it, you realize that we are having sp2 because it's double bond. Carbon 2 is having sp3 because it's saturated. Carbon 3 is having sp2 because it's double bond. Then carbon 4 connecting to carbon 3 is still having the same sp2. Carbon 5 is having sp3 because it's saturated. But carbon 6 is having sp because it's unsaturated. Carbon 7 is also having sp because they are unsaturated. Now, if you look at carbon 6 and 7, they are super unsaturated because they have triple bond. So when you're talking about the carbon, you go and look at the carbon and look at the bond connecting the carbon by your left and by your right. If there are double bonds, whether left or right, it changes the hybridization of that carbon. For a carbon to be purely saturated, like carbon number 5, you realize that at carbon number 5, the left and right is saturated. That's why 5 is sp3. Look at carbon number 2, left and right is saturated. That's why it is sp3. So whenever you're talking about the hybridization of the carbon, look at the left and right. If there is no double bond, it's saturated. But if there is double bond left or right, it affects the hybridization of that particular carbon in question. Now, this question now is what is the hybridization of each carbon bond as presented in the chemical compound? The bond. There is difference between carbon atom and carbon bond. When the question is talking about carbon atom, I'm talking about one single hybridization. When the question is talking about carbon bond, it means that these two carbons, what is the connection, the hybridization between them, the bond? When you're talking about bond, you're talking about two carbon atoms that are connected by that bond. So example is A and B. If you look at A and B, you realize that A, the hybridization of A is sp3, the hybridization of B is sp2. So the bonding of A and B is sp3, sp2. You can also say sp2, sp3, depending on how the options come. But if it is in theory, you can use sp2, sp3 or sp3, sp2. Whenever you're given a question of carbon bond, the first thing you need to do is to go and indicate the individual hybridization of each of the carbon atoms in the compound. So if I'm giving this in exam, I will come and write under A, sp3, B, sp2, C, sp2, D, sp, E, sp, F, sp3, G, sp3. So after knowing that, then if what I need to do is now I'll go. So since I know that A is sp3, B is sp2, so my AB is sp3, sp2. BC is sp2, sp2. CD is sp2, sp. EF is sp, sp3. While FG is sp3, sp3. So the carbon atom is one single hybridization. Carbon bond is two hybridization, which is the hybridization of two atoms connected by a bond. I hope that's clear. Which of the options represent the hybridization of nitrogen, carbon 1 and carbon 2 respectively? When you see this question, what you need to do is that, remember, respectively means that nitrogen first before carbon 1 and carbon 2. You have to understand the question before you answer. Now, like said in the example we talk about, the hybridization of primary amine is sp3. When you look at the carbon number 1, it's saturated system. So the hybridization of that carbon is sp3. The carbon number 2 is oxygen that bears double bond. So the hybridization is sp2. So my option becomes sp3, sp3, sp2. So whenever you're given a question, try to solve it before going for the option, so you don't waste your time. Remember, they say respectively. It means that I have to do them accordingly. What are the hybridization or nature of bond of the carbon or bond indicated by the arrow? Now this is combining atom and bond. So wherever you see arrow that is in between the two, that is not on the atom, it becomes bond. The I is talking about atom, and that I is triple bond, making it sp. II is talking about bond. So in that case, I'm talking about the hybridization of the carbon, of the two carbons that is connected by that bond. You realize it is sp2, sp2. If you look at III, they're talking about the hybridization of the carbon, which is saturated system, making it sp3. You look at IV, it's talking about the hybridization of the carbon, which is double bond in a ring, making it sp2. Then look at V. V is not talking about carbon, it's talking about bond, meaning that the sp2 bond is connected by sp3 bond. So we have sp2, sp3. So understand the difference between hybridization of carbon and hybridization of bond. Carbon is going to have one hybridization, bond is going to have two hybridization, which means hybridization of the carbons that are connected by the bond. End of hybridization. If you go through this very well, you will not fail any question in hybridization. I wish you success in your organic chemistry exams. Thank you.